What up? Tyler here from TarverAcademy.com. I want to hit you with some properties of real numbers. The first property I want to talk about is the commutative property of addition. Commutative property of addition. What that means is A plus B equals B plus A. You're thinking, oh, that seems pretty easy. Well, you would be correct. It is pretty easy. All you're looking at doing here is you take two numbers, 3 plus 7, and you can flip them. 7 plus 3. And it's going to equal the same thing. 3 plus 7 is 10. 7 plus 3 is 10. Boom. All right? That is not the same story with subtraction. Therefore, there's not a commutative property of subtraction because it would mix it up. Put a negative 3 there, negative 3 there. Actually, that would be the same thing. So it would work with that. You know what? I'm keeping this because I'm going to be real with you guys. I'm going to be real with you. I wasn't thinking right. I was thinking of, what was I thinking of? Doesn't matter. Nothing hard. Okay. Commutative property of addition means that you can add two things together and you can flip them and add them together and they're going to equal the exact same thing. What up? Tyler here. I want to talk to you about the commutative property of multiplication. Okay, so if you were with me last time on the commutative property of addition, you knew that something plus something is equal to flipping that and adding it together. Same thing here. It means you can reorder a multiplication problem and you'll get the exact same answer. So for instance, 3 times 7 is equal to the same as 7 times 3. It comes in handy whenever you have a chunk of stuff you're multiplying. It doesn't matter which order you put those in, you're gonna get the same answer. So it's pretty convenient. You don't you never really say this phrase, but it's good to know it because it's one of the pillars that doing mathematical equations is based on. What up? Tyler here. Okay, so I want to hit you with the associative property of multiplication. What that is, it means that A times B multiplied first times C is the same as if you multiplied B times C first and then multiplied A. It's very similar to the commutative property of multiplication, but the commutative property only applies to two variables, two numbers being multiplied in whichever order, equaling the same thing. Here, you're saying you can take three of these three numbers and multiply them together and then mix them up and multiply them in a different order. As long as they're all just being multiplied together, it's going to be the same thing. The way I like to think of it is you associate with one group of people. Here, you can mix up and talk to the same group, different people in the group, and you're associating with them here. It's all the same. It was a terrible example, but I'm going to stick with it. So let's look at a problem like 3 times 7 times 2, and then 3 times 7 times 2. All right? That's saying that this is going to be equal to this. This is going to be the same thing. So when we're solving equations, that's good to know. It's something we won't really think of, but it's something we have to know we're able to do. And most of us never questioned that we could do it, but here we are. So let's solve it and make sure. I'm going to do a little split line so I don't cross over. 3 times 7 is 21. Times 2 is 42. Hopefully that'll be equal. 7 times 2 is 14. 14 times 3 is 42. I don't know why I wrote 3. 42. So it does work. It should. It's one of the main properties in math. So, what up, ladies and gentlemen? Tyler here with TarverAcademy.com, and I want to talk to you about the associative property of addition. Very similar to the associative property of multiplication. Also very similar to the commutative property of addition. That was it. They're very similar to both of those, which means that pretty much all four of those, the commutative property of addition and multiplication, and then the associative property of addition and multiplication, all four of those essentially mean that you can add in any order or multiply in any order, and it's going to equal the addition of those orders or the multiplications of those orders. But I'm going to show you this because I want to round out the set. All right, what the associative property of addition says is that you can add three numbers in any order and still get the same answer. Okay, it's something you won't need to know very often or utilize very often, but it's something that needs to happen for you to be able to solve equations. So it's something you'll use, but it's not something you'll think, oh, I'm gonna have to know that I have to use the associative property of addition. Because you don't really use proofs that much anymore, so you don't have to write it out, but it's something you need to know. Okay? So let's use actual numbers. So let's A is 2, B is 7, and C is 3. So 2 plus 7 plus 3. Okay, so now we're going to solve it. Let's solve this side first. 2 plus 7 is 9, plus 3, 9 plus 3 is 12. All right, now on this one, we got to do order operations, 7 plus 3 first. So 2 plus 10, 2 plus 10 is 12. 12 equals 12. Of course it does, because of the associative property of addition. Boom! What up? Tyler here from TarverAcademy.com, and I'm going to hit you with the distributive property, okay? We're going to talk about the basic concept of the property, and then I'll show you an example. So here we go. Talk about the distributive property. Distribute means that you hand things out equally. So, for instance, if I had a loaf of bread and I want to distribute it to 4 people sitting at a table, I would cut it into 4 pieces and give one to each person. That's distributing. You're distributing something out. So here we go. The distributive property. It means that if you've got a number and you're multiplying it times 2 numbers that are being added together or subtracted, that means that you're going to distribute it to both of the numbers. So A times B plus A times C. So it means that whenever you're multiplying something in there, it's going to go to everything. Okay? So let's do an example problem, shall we? 7, and then let's say 2 plus 3. And then we know we can work this. Like we distribute the 7 in there. It'll be 7 times 2. But I'm just going to write it over here. So 7 times 3. It's saying that this equals this. And when you work these equations, it means that you're going to push. You're going to work an equation out. Like this is what you'll start with, and then you'll work over to this. It just means that this property allows you to take that step in solving an equation. Okay? So you're not going to think about the distributive property, but you will think, okay, I need to distribute here. But if you ever had to write a proof, this is the property you would utilize. Okay. So let's make sure it works. I'm going to work this side and show you that it works out. So 2 plus 3 is 5, and then 7 times 5 is 35. Let's make sure this side works out. 7 times 2 is 14, plus 7 times 3 is 21. 14 plus 21 is 35. And of course that works because of the distributive property. All right, thanks for tuning in. Peace. What up? Tyler here, TarverAcademy.com. I want to hit you with what deductive reasoning is. Deductive reasoning is coming to a logical conclusion by utilizing facts. Okay? So essentially what you're going to do is you're going to show steps to how you're solving a problem, and the reason, those are the facts that allow you to do that. Another way you like to see people do this is writing proofs. You don't see that as much anymore, but we like to call it deductive reasoning. So it's utilizing and solving an equation or breaking something down and then using facts, using logical things that you can prove. That's deductive reasoning. Okay? So we want to solve negative 4b plus 9 plus b, and then I want to show reasons for why I'm able to do it. We're going to utilize a lot of the, sorry, Mr. Eraser. We're going to utilize a lot of the formulas and properties, not formulas, but the properties that we used earlier in the chapter. Okay? So the first thing I'm going to do is I need to get this to where there's a number in front of that b. And so I'm going to do negative 4b plus 9 plus 1b. All right, all I've done from this problem to here is I've put a 1 in front of the b. It looks like 16, but it's a b, sorry. All right, now the property that we utilize for that, if you remember, is the identity property, identity property of multiplication, which was, if you remember, anything times 1 is itself. And so I can put a 1 in front of it, I can add a 1 to it, I can multiply 1 times it, and it still would be itself. I'm not changing the problem because of that property. All right, next thing I want to do is I want to reorder this. I want to put it where I've got this over here, something there, and then something there. So I'm going to do negative 4b. I'm going to move this plus 1b plus 9. Now I want to think, what property allows me to say that 9 plus 1b is the same as 1b plus 9, switching around. We're adding, so I know that addition is going to be involved. and I'm just moving stuff around, so that's only moving 2 things around, which is commutative. If I'd have put 3 things in there, it would have been associative. You think, oh, well, there's 3 things there. I didn't move this, okay? I just moved that. So we're going to say that's the commutative property of addition. Okay. Now, I want to pull, let's say I want to pull something out of this. Let's say I want to pull, let's see, what do I want to pull? What can I pull out of this? The common thing here is the b. So let's say I want to pull the b out of all this, multiply it out, -4 plus 1 plus 9. That's going to be our distributive property. I didn't distribute it in, I distributed it out. So it works both ways in the distributive property. If you remember from previous things. That looks like 2 E's. It's reasoning. Sorry. My handwriting's garbage. Okay? And then I want to add these together, and I can make that the b. That'd be -3 plus 9. Oh, I forgot. This is distributive property. And then the last thing I did was I rearranged and added, and that'd be that's just addition. So it's not really a property, I just used addition, so it didn't say property in it. So that's more complicated. If you want to see a better explanation, in my opinion, of how I did that, just search Tyler Tarver, algebraic proofs or geometric proofs. They're killing it. They're killing it. Thanks for tuning in. Thanks for learning. Oh, hey, it's me, Michael Jordan, Shoemaker. I want you to know that if you don't click that little circle there to subscribe, then you won't ever find your true love. That's a fact. It's like an email chain letter. If you're not 45 years old, you will not get that joke. Not important, but you click that. Anyways, I'll wait.